Okay, I'm gonna use the whiteboard for this. I've got some different shapes up here, and we talked about some of the shapes when we kind of got into circles and even triangles there. We talked about some of the shapes, but I'm gonna repeat that. And then what we're gonna look at for right now is the area of these shapes. And this will be our last kind of little bit, and it's gonna be um, not very long, just because we only have a few days, and then our final will be next week. But I wanted to go through some of these, give you these formulas. Now, here's the thing about formulas, and especially this kind of geometry, is, you know, the formulas, you're going to want to learn them, but at the same time, memorization really is not as big as a thing anymore, just because we can always, you know, when I was in school, I remember, you know, teachers, you can't always look that up. Well, you kind of can now, you know, if you've got access to your phone, internet. But we definitely need to know how to use them, have some familiarity with them, and know what they mean. But I want to go through some of these areas of these, most common shapes, and discuss that a little bit, and then work some problems with it. Have you work some problems? But I started with a rectangle here. Now, the special characteristics of a rectangle is it's got four sides, so it's a quadrilateral. Okay, and we talked about quadrilateral before, meaning four sides. And so that's one of the special characteristics. Also, it's got all 90-degree angles, so all the angles are 90 degrees. Okay, and this side is going to be the same length as this side, and this side is going to be the same length as this side. If you start to change from that, kind of get into this territory, then it's not a rectangle anymore. You know, and so another thing about it is, you know, these are parallels. Each side is parallel to each other. So you've got special things going on, but we can always usually recognize a rectangle. Now, one nice thing about rectangles, if this is 5, then this over here is 5. If this is 8, then this up here is 8, that kind of thing. All you need to know for an area of a rectangle is that you take base times height. Okay, so we just take 8 times 5, and our area of this is 40. Now, when we're talking about area, I want to, and some of this I've went through before, but it's been probably since the beginning of the term or even midway through. So I want to reiterate, and some of this too we discussed in Math Lab and pre-algebra. So, you know, it kind of goes back a little bit, but basically perimeter, the word perimeter means you're going around, the distance around. Like if I took a piece of string and wanted to know how long that string needed to be. In real terms, like thinking about a house or something, you would need to know, like if you were putting up baseboard around the edges, and you just need to know how much the length of the baseboard needs to be. That's perimeter, that's going around. That's when you do the adding, where you add 8, 5, 8, and 5, okay, and get 26. So that is perimeter. Area is talking about all of the area that this covers. So it'd be like the carpet, okay? If you needed to put carpet, or if this was a wall and you needed to paint it, and you need to know how much surface area, sometimes they refer to it as surface area, that you have to cover. So that is what we're doing with these area formulas, finding the area. So that's why we do the 8 times 5, which is 40. And if it's, let's say feet, let's say you're doing a wall, then it would be, because you're doing 8 times 5 is 40, you're also doing foot times foot, which is feet squared. Remember, if you multiply anything times itself, it's squared. So this is 40 feet squared. If it had been inches, then it would be 40 inches squared. Now, I'm not necessarily going to count you wrong for not putting this at this point, but it is important to know that difference. You would not walk in and say, I need 40 feet of carpet. You would say, I need 40 square feet of carpet if you were buying carpet, okay? So that is the difference there. But all you have to do for a rectangle is base times height. Now, what's nice about that, it doesn't matter which way this shape is turned, okay? If we turned it up on its side and was sitting up like this, you said, well, didn't the base and height change? Now this is 5 and this is 8. It did. This is your height now, this is your base, but it's still going to be 40. So if we turn this, it's not going to change the area. We still have to cover the same amount of area. It just, now your base and height are different, but you're still multiplying, so it doesn't matter what order you're multiplying, it's still going to be 40. Okay, so that's one important thing about that. Another thing is to just draw the difference between volume. Okay, we're not filling this up with anything. This is not a three-dimensional shape. So I can't hold this box, I can't hold this in my hands, it's on the board. And like if you think about carpeting a floor, you can't put anything in the floor, meaning, you know, it doesn't hold anything, it's a surface. Same thing with a wall, okay? Now, if you're talking about the whole room as a rectangle box, then you can talk about volume, putting something in it, like a gas, an air, or a solid, filling it with concrete or something. That's when you begin to talk about volume, and that's a whole nother, you gotta get length times width times height, you gotta, there's other formulas, and you end up cubing things because you're multiplying 3, you know, dimensions. So right now we're just talking about covering a surface. So, you know, that's what we're talking about when we're talking about area. Okay, so that's a rectangle. Square, same thing, it's got 4 sides. It also has 90-degree angles. Okay, the sides opposite each other, parallel. Okay, and they also are the same length. Now you say, well, then why isn't it a rectangle? Well, what makes it special, what makes it a square is all the sides are the same length. So if this is 4, then they're all 4. Okay, and that's what makes it a square, not a rectangle. Square has the characteristics of a rectangle. When I did that quadrilateral thing, you know, and we talked about how square puts all of the rhombus and the rectangle and all the quadrilateral, it puts all of it into that one shape. Okay, that's what we were talking about. Now, the area formula for a square is written like this, side squared. And what that means is you only need to know one side, okay, 4, and all the sides are 4, so all you need to do is square that. So 4 times 4 is 16. 16, if let's say we're doing feet, 16 square feet. Now, if that, you know, to me, I think it's just as easy to remember you're still doing base times height, just like you did on rectangle. You're still doing 4 times 4. You still get, you know, this times this. What kind of makes it different is with a square, if they tell you it's a square, you only need to know one side. If it's a rectangle, you need to know at least these 2 sides. You can't just have this and be able to figure out the area. You don't know what this length is to multiply it. With this, all you need to know is one of them is 4, and they're all 4, okay? But you still just do like a base times height, okay? So that's the area of a square, okay? This is a parallelogram, and what you noticed is, I'm gonna erase this for just a second, and it's not a rectangle, and the only reason why it's not a rectangle, these are not 90-degree angles, okay? It'd be like if you took a deck of cards, okay, just picture in your mind, you took a deck of cards, you stacked them, and everything was straight, you straightened the edges, everything was straight, you'd have a rectangle sitting there, but if you took the top cards and just slid them over, okay, no longer is this a 90-degree angle, it's slanted, that's what you have right here. So this is a parallelogram, okay, now, what makes it a parallelogram, I'm still saying that these sides are parallel, and that these sides are parallel, so it's like a rectangle in that way. The only thing is they're not 90-degree angles anymore. In this case, this side is still going to be the same length as this side, and let's say this is 6, and let's say this is 10, okay? So this is 6 and 10. So you say, well, all I need to do then is multiply 6 times 10. That's not true. And the reason for that is if it was that easy, then it would just be the same as a rectangle. And you say, well, it is the same. But this, because we tilted it, we have changed this height. If you walked into a room, you would not take if someone said, how tall is this room? You would not take a ruler and start to go up to see how tall it was and tilt the ruler like you've done here and say, well, you know, go diagonally and say the room is this tall. That would make this wrong. It would not be 6 because you've tilted the thing. So what you have to do is you have to find this height right here. Go straight up and down and form a 90-degree with the floor. So I'd have to take that ruler, go straight up and down and find out what the height of the room is. And it's not going to be 6, it's going to be something less than 6. Because when you go straight up and down, it takes less of the ruler, right? If I tried to take a ruler and go all the way to the corner and angle it, that's going to be a really long ways compared to going straight up and down, okay? So you have to know what this height is. And in the problems that you'll be given this. You don't have to, you know, sometimes, you know, if you get further, you can work out a Pythagorean theorem and figure it out. But in this case, the height will be given to you, so let's say it's about 4. Okay, then you're going to take base times this height, and so it's 40. Okay? So that is the difference there. If it's tilted at all and you don't have 90-degree angles, don't use the side that's tilted, okay? You need to find the height. And it'll usually be a dotted line given to you in your problems that you can then take it, the base times the height, okay? All right, so then triangles. Now I put several different kinds. We've talked about all these kinds. We've got equilateral, a right triangle, obtuse. This one's an acute. So we've got all different kinds of triangles. Well, the formula is the same for them all. It's just finding the height and the base is different, just like these two things are different, okay? But the formula is, it's base times height still, okay? So you take, and you say, well, what about this half? Well, if you're doing it on a calculator, the best thing to do is do base times height. Do it first, because everybody hates fractions, right? So do it first, do base times height. Then when you're done with that, just divide it by 2. That's all you're doing when you half something. If you had a candy bar, and you half it, you divide the candy bar in 2. So you're going to take base times height and then just half that number. Now that's an important thing. You can't forget to do that, but all you do at the end of it is divide it by 2. So we need to look through here and say, well, what's my base in height, okay? Once again, let's say this is an equilateral triangle and all of these are 3, okay? You say, okay, well, it's sitting on its base, this is the height. Nope, it's slanted. Okay, so you're not gonna say that the height of this triangle is a ruler that you've slanted. The height of the triangle would be like standing on the base here and going straight up with a ruler. Now that's gonna be shorter than this because you've not tilted it. So let's say it's about 2. Okay, so using my formula, I'm going to take the base times the height, which is 6, and I'm going to divide that by 2 when I'm done. So I did the base times the height first, got 6, and then I divided it by 2. So my area is 3, and if it's, I probably should use feet every time so that we get into practice that. 3 feet squared. Okay? So that's an equilateral triangle. Well, here we got a right triangle. These are actually a little bit easier because if, let's say this base is 8, and let's say the height here is 6, okay? Well, if you're standing here at the base and you say, well, how tall is the triangle? This is how tall. You got a straight ruler, okay? You've got your 90 degrees here, so you've taken that ruler straight up. So this is already the base and height. You don't have to have an extra thing like here that shows you exactly straight up and down. You've got that right here, okay? So your base and your height, 8 times 6 is 48, okay? And don't forget to divide by 2 when you're done. So 24, and we'll make it feet squared. Okay? So same thing, base times height divided by 2. Here's 2 different triangles that we can use that on. Now here is an obtuse triangle, and let's say this is, let's make it 6, let's make this 10, and once again, you're standing here and you're saying, how tall is this triangle? How tall does it go? Would you take your ruler and go diagonally and try to find that? No. You would stand out here, so we need to kind of picture ourselves standing out here. I'll draw a little stick figure. Hey, I'm standing here and I'm saying, how tall is this? Well, I'm going to go straight up with this, and that's going to be my height. Okay, here's my base. It's still 6, but I'm going to stand out here and I'm going to be like, how tall, if this is my base, if it's sitting on this, if this triangle is sitting here, how tall is it? Okay, and so you would look straight up, and so this would be need to give to you, and let's say it's about 5. Okay, so we've got 6, 5, 10, and so we need to know which ones to use. Well, this one's irrelevant. We're not even going to use it. It doesn't tell us anything. It's not the base, it's not sitting on it, it's not the height. We don't need it. So we're just going to do 6 times 5, base times height, which is 30. Okay? And then I'm going to divide that by 2, which is 15 feet squared. Okay? So here's, equilateral, right triangle, obtuse, what you have to do to find that height. Okay? And here's an acute triangle. It's almost like the equilateral, but it's not, because it's now scalene or isosceles. But we basically, what we've done, okay, let's say this is a base, okay, let's make it 20 feet. And let's say, just to show you, I could put 3 measurements on there. Let's say this is 22 feet. And let's say this is, we'll make it 10 feet. Well, let's picture this as our base. It's going to sit on this. Now you could, later if you flip the triangle around, did it another way, you could use this as your base and you have to work out from there. But right now this one's easy to see. Sitting on it, it's 20 feet. That's our base. Okay, so I ask you, is that the height? Would you take a ruler in this corner and try to say that's the height of the triangle? No. Once again, would you take a ruler, stand out here, and go diagonal? No. You would stand and say, okay, I need to stand inside. Now this one we stood outside, but you would need to stand inside here and look straight up and form your 90 degree. Here I am standing inside. I'm like, okay, I'm going to take the ruler and go straight up to the tip, form a 90 degree so that my ruler is straight up and down, and this is my height. Okay, and let's say the height on this one's about 8. Okay? So we've got all these numbers, we need to know which ones to multiply. Well, base is 20, height is 8. That's the only two that I need. 20 times 8, which is 160. Okay, and I'm going to divide it by 2 at the end, because it's a triangle. It's 80 feet squared. Okay? So go back, like I said, I know I'm giving these quick, giving you one example, but I tried to give you every kind of triangle that you could see. They're going to always be a little bit different, but you're either going to have a equilateral, right one, two, acute, different variations of that, but that's what you use. You've always got to have a base and a 90 degree height, okay? Then just multiply those two, and the important thing about a triangle is make sure you half it, okay? Circle, we just got done doing. I wanted to go ahead and remind you though, it's still talking about the area of the circle. So like if I was to paint this, or if I had a circular room and wanted to lay carpet in a circle, that is covering the area. That is what that is. And so we just did this. So if you had a circle and you knew the radius was 3, okay, then you square that, which is 9, and you would take that times pi, which would be somewhere around 27.3 or something. Okay, or 20, maybe a little bit bigger than that, but it'd be in that 3.14, so times 9, so it'd actually probably be about 28. So anyway, that is what you're doing there. Still feet squared. So let me go ahead and do it, because that's gonna just drive me crazy. 28.26. So let's round up 28.3. Okay, feet squared. Okay? We just got done doing circles, so that is what you do with that. Okay, but I wanted to remind you, we're still finding the area just like we were finding the areas on these shapes. Okay, this last one for today is a trapezoid. And I didn't really necessarily, when we went through quadrilaterals, I mentioned this, but I didn't necessarily go that deep into it. I do want to highlight the differences between a trapezoid and those other quadrilaterals. First thing is it has 4 sides, so it is a quadrilateral, okay, but it's different than a rectangle because obviously not all the sides are parallel, so that makes it different than a parallelogram and also different than a square. One thing about trapezoids though is at least 2 of the sides are parallel. Okay, so you don't just have some random 4-sided shape that looks like this, okay? Well, that's almost a trapezoid. Huh. Let's go more. I'll do that kind of thing. So something like that, where you've got 1, 2, 3, 4 sides, but none of them are parallel. There's no rhyme or reason. Now you could still find an area of this shape, but you'd have to break it into parts. Okay, you'd have to either work out where you've got a rectangle here, and then a triangle, and kind of go from there. So you can maybe do like cut it into parts, do a rectangle, do a triangle, and add them all together. So there's ways to do that, but there's no formula for a shape that's just any which way. So that's where it has to fall into these to use these formulas. Now what makes a trapezoid is these 2 sides are parallel. On this one, it looks a little bit different, but at least these two sides are parallel. Okay, now the other two sides are not. These are not parallel. They don't run, they're eventually going to run into each other. Same thing with this. Eventually, if I extended this out, eventually they're going to run into each other. So two of the sides are not parallel, but the other two are. That's what makes this a trapezoid. And that formula is a little bit more to it, but really when you break it down, it's not that. It looks kind of crazy, but it's really not. Okay, all this means is we're going to half it at the end. Okay, so just like we did with a triangle, at the very end of our problem, we'll divide it by 2. But this part right here is a little bit different than the rest. This b1 plus b2 is not, these are not exponents, so we're not squaring them. They're not above the letters, so I want to point that out. They're below them. And what it means is you've got two bases. You've got a base here and a base here. Okay, in this case, we're going to use both bases, base 1 and base 2. And they're going to be different, as you can see. This one's shorter than this one's shorter than this one. So they're going to be different numbers. Okay, so let me use this as an example. Let's say we got 8 and 10. Okay, and let's say these are the same. Let's say these are 4 and 4. Okay, so the first thing I'm going to do is say, okay, base 1, base 2. So all you do, because they're in parentheses, you're going to do this first. Now our PEMDAS comes into play. So we're going to add these up first. Okay, so 10 and 8 is 18. So that's what you're doing with base 1 and base 2. You're adding up the bases. You say, well, how do you know they're bases? Because they're the parallel sides. Okay, so 8 plus 10, 18. Okay, and now we need to multiply it times the height. We're going to do that, and then at the very end, remember I said we're going to divide by 2. Sometimes you'll see this formula written like this, in fact. Sometimes people write it like that, meaning do all this first and then divide by 2, and that's fine. There's other ways to write this. But basically, we've done this part, now we need to find the height. Well, I go back to my question. Would you take a ruler and turn it and go diagonally? No. You have to have the height of the shape, okay? And they will give you that for your problems. Now, later down the road, like I said, if you keep going with further math and stuff and we have more time, we could figure out the height maybe if we use the Pythagorean theorem. But in this case, they'll give us the height, which in this case would probably be around 3. And so we've got this 3 here, that's our height. So we do the 18, that's what we got from base 1 plus base 2, times 3, okay, the height. And that's going to be 54, okay. And then at the very end, make sure you half that, so you got 27, okay. Let's do another one, because this one looks a little bit different than this one. Okay, let's say this is a 90-degree angle. Let's say this is 20. Let's say this is 10. Let's say this is 8. And let's say this is 6. Okay, so we've got the shape here. We're trying to plug it into our formula. The first thing we know, these are the parallel sides, so we can add them. So 20 plus 10 is 30. Okay, that's my base 1 plus base 2. The height. Okay, so is it a ruler that's diagonal? No. Do I need to draw one, or is one already given with a 90-degree height? Meaning I'm standing here, it's exactly this tall because the ruler goes straight up and down? Yes, so we don't have to have another one given to us. See, these, both of them were turned. This one forms the 90-degree, so it's as tall as this shape is going to be. So this is 6, so 2 bases added together give me 30. The height is 6. Which 30 times 6 is 180. Okay, and then at the very end, don't forget to half it, which is 90. And if we're dealing with feet, it's still feet squared. Okay, so those are, I know, a little bit of a crash course there, but go back through, watch them, kind of just keep referring back to your formulas. Obviously, these are going to be the more simple ones. Okay, a triangle or a rectangle and square. These on the parallelograms, just make sure you find a height or use the right height. Triangles, it's this formula every time, but sometimes the height are in different spots. Okay, just always remember you want to form the 90-degree. It's what forms the 90-degree angle. Go straight up and down. And then with the trapezoid or a circle, we just got done doing that. Just need a radius. That's what you need. What happens if they give you a diameter? So let's say they give you one that's 10, okay, and you're trying to do area, remember you need to half that number. So the radius would be 5, so you're going to square 5, which is 25, times pi, which would be somewhere around 78 or something, okay? Okay, so that is what you're doing with these trapezoids. Add the two bases times height, and then half it at the end, all right? So I'm going to have some problems probably for you on this, and get you some practice. Well, I'll go ahead and write some up there. That'd probably be the easiest thing. Okay. Let's see. Let's do a rectangle, and you don't have to draw these. I'm just drawing them for you so you can see. And let's do 7 and 10. This is a square. Let's see. Let's do a 12. These are all feet. Okay, I'm going to do a parallelogram here. I'm going to make it look a little bit different, but it's still a parallelogram. Okay, I'm going to do some triangles. I'm going to mix it up though, not do them in the exact same order. Remember that means 90 degrees. Okay, so that length is 3. These are all 4, equilateral. Running out of board space here. That's going to look confusing. This length is 12. This length will be 8. Okay. And then let me do a couple. We've done circles recently, so let me do a couple trapezoids. I'll start here. So these would be trapezoids. What number is this? Number 8. Okay. Okay, so those 9 problems, and work those with your formulas, and go back through. Probably need to rewatch, compare the two, make sure you're doing the right formula with the right shape, and we'll go from there. Oh, let me turn this so, yeah, that way you can see everything.